Okay, looks like we're live. This is going to be my first meta learning vlog on systems thinking. What I'm trying to do is share a meta learning concept where I'm passionate about learning, so I'm going to try and learn a new topic and then record it and then like capture what I'm learning by watching this video here on systems thinking. Um, but before I start that, I want to just talk about what I what I know about it right now, which isn't cohesive, but at least it'll explain where I'm grounded at before I watch this video to learn more. So this, this is a tool I use called Miro to really put together my thoughts, and I really became fascinated with this idea about thinking that my questions of why always lead to an infinite way up or down, and they both end in theory. So if I was to think about why we're here, why the world exists, it's quite a rabbit hole either way. So I have a map here that I try to use as a visual way for me to understand what we're doing when we're thinking about a system. So I'm going to zoom in here, and I'm already getting a little bit buggy on my internet feed, or maybe that's the max zoom. But so there's this idea that we're looking out. So from the things in front of us to farther out the horizon, you start to see patterns that are very interesting. This is a very interesting pattern here. And then fractals, you can see fractals here, and then these these patterns are kind of like our veins or blood vessels, which is really cool that you could see that in the world around you. So as you look out, you go from seeing the world around you to having satellite dishes looking down on us, and now having a view of fractals around a coastline, the world as its own entity, and then farther out other planets, and you see that perspective, that point of view that's looking out. So that's why I have this captured this way. So we're looking out as one point of view about what we think is beyond, right? So you're looking out, where are we in the universe? What's out there? And we can go farther and farther, and we have powerful computers that then model what we think is beyond what our human eye can see. So then we have computers that help us interpret, galaxies and universes and structures of what the actual universe looks out way out there, which is cool, because then you see more patterns here, right? So a spiral galaxy, well, you see the spiral pattern in nature, and so this is all of the known universe that we can capture right now with our telescopes to do mathematical models that say this is what we think it looks like, which is absolutely insane that we can have something that looks like this. But it is it is really cool that you could say, well, this looks a lot like a neural network in our brain, and how we have networks of thought, and our universe is structured that way. So this is me, thinking about that. Right here's what a neuron looks like, what a cluster of galaxies looks like, and it has this similar pattern of things repeating themselves. And then we have this theory about reaching the end of that model, to say, well, we hit the end. There's multiple theories about how that started, why it is. We still don't know. I mean, it's just a theory that there's these ideas that maybe it started like this with the Big Bang. But that's not the only theory. It's just to say that at some point you come to an end, or not an end. I don't want to call it an end, but at some point you come to, like, all right, we've hit theory. There's multiple ways that we can talk about that far out, and nobody has a concrete answer. It's there's multiple theories. So that's one way to say that nobody has the answer, but we have good ideas and good theories. Okay, so that's going out, looking out, and that is a form of reasoning, and this is just patterns in nature that I'm fascinated with when you can see these patterns. And then the reductionist point of view, or to go down, to go within, right? So let's go down the opposite spectrum, uh, right? So we went from looking out, individual, family, ecosystem, society, and then you go out, looking at nature, the world. Now let's go down. So we go within. Um, oh, what do I got going on here? Yeah, I guess what I'm trying to get at here is that I got a little crazy on looking at patterns, but so be it. The idea I wanted to capture here was that we look at things smaller. That's what I was trying to do, and in time spans to see life forms getting reduced to, well, what were we before humans? Were we other living species that have evolved? And we go down and we look at ourselves and we look at our cells. We look at what we're made of biologically, and we go down. We ask ourselves, are we trillions and trillions of cells? So now we're going down. We went with the other way. We looked at the microscope looking up. Now or telescope looking up. Now we're looking at a microscope going down and asking ourselves what we're made of. And then you'll see patterns again, which were cool to look at the other way when you see a river and how it moves through the landscape. Well, we have these patterns inside of our body and on Earth that repeat these fractal tree-like structures. And then we get down to atomic structures and say, well, if we keep going beyond us as a human species, what became before us? How did that come to be? What are these elements made of? And we start breaking everything down, and we say, well, they're all components of relationships of atomic structures that say, if you put these things together, you get something that looks or it behaves like this. Keep going down, and you're now, so we're getting to the degree of challenging some of the theories of what happens going down. Is it beyond the atomic structure, and then physics, quantum physics? What's that? That's a new, no, I shouldn't say new, but that's another paradigm of trying to understand what happens at that world we can't see, and then we use models down at this level to start trying to imagine what the world looks like beyond atoms smashing together, right? So there's this idea that you can't split an atom, you can only go so far, and then really at the base of us is this vibrating energy, and that's what matter is. And quantum computing is I believe, and I could be wrong, an idea that is still trying to look further at the depths of what makes up matter. Can it be more than what we currently know? Then I like to think about it as, at that level, you have all these, like, I mean, the idea of a thought alone, neurons firing in your brain, is similar to the pattern that we talked about when we looked up. So you looked up, you were looking at the universe of structure. When you look within, we have this structure of thought that goes through our biological matter, but that is like going down and thinking about the thought itself. How is a thought at the atomic vibrating structure? And then you have people having theories about this level of depth. Are you in a simulation, or is there really an external world, right? This is a really deep thought about if you reduce to thought as being a biological process that moves through a network that is explaining what is out there, it's really hard to get my head around understanding, well, how far can you go down the rabbit hole to understand thought? Where does it come from? Am I, are you in a simulation? I don't know. Anyways, so it's quite deep that system thinking can go one way or another. You can go up or down, and you end up back at the same spot. That's what I really want to get to. You can go up or down, and you still come back to theory. Nobody knows, right? No, everybody has ideas. Everybody has ideas about how far you can go one way or the other. So that's what I'm fascinated about this concept. So with that, I dropped a board here. What we're going to do is watch this video, and I'm going to try and capture notes while I'm learning systems thinking for newcomers, right? So I told you like my fascination with it. So let's open a link here. Fascinated. It started landing on, where is it? Okay, there. I landed on Derek and Laura Cabrera, I think, a couple years ago. Yeah, okay. I have this book here. I don't know if you can see that, but this is their book called Thinking at Every Desk. Four simple skills to transfer your classroom. Well, it's really, I wanted my children to have a model that they could use as a lattice or a cognitive baseline, that if they knew a mental model at a very young age of systems thinking, that they could, or they'll inevitably come to probably this thought, like many of us do, is, why am I why am I here? How did we get here? Why do we exist? And these are questions that just they can't be answered, or they might not be answered in my lifetime. But right, at least there's a way that you can model the world around you to some degree to say, well, we can look at our system that we're in, a system of thought, a system of observation of what you're looking at least try to have some sort of model or a map to say, look, we may not have the answers up, all the way up or all the way down, but what we do know is, a lot of this space in between. So have some fun, have some fun in this space, because, we're only here for 90-ish years. You can spend your whole life trying to figure out if the Big Bang is real, or the reason how it all started, or meditate your whole life, and you can do those things, or those are spectrums. Or you could say, this is absolutely fascinating that we exist, and have a whole lot of fun in between. So it fascinates me. Got their book, got our tutor that's teaching our kids right now to instill the principles of this model, the DSRP model: distinctions, relationships. What is the distinctions, relationships, DSRP? No, distinctions, systems, relationships, perspectives. That's what I want them to know. I want them to get that, and then they're good. Then they have a model. Okay, that's enough of me rambling on. Let's do the meta learning part, whereas I'm going to watch this video. I don't know everything. This one is good too. So Russell L. Ackoff. This guy's funny, but good, excellent wisdom here. If you're interested in systems thinking, watch this video. and I don't have a way to port the audio through, um, or actually, I just don't know how to do it yet through OBS. So whatever, it's going to be playing in the background, but I'm going to speak to it anyway. So let's see what he says.
Again, completely different in ours, and emphasized the question of what's responsible for those differences, and became curious about man. Now, in one obscure encyclical during the Middle Ages, curiosity was actually declared as a sin. But despite that, like birth control today, people ignore it. And so they began to inquire into the nature of man and his environment. And that led to the movement called the Renaissance. And Renaissance, as you know, is a French word which means what? Rebirth. It was the re-entering of man into this world. Now,
I'm not. I'll just leave this here because if you're watching this later, you can see the link. Well, one of the cool things about Miro is I have all these linked out. So this board is really a great structure that as it's a great tool. This is a systems thinking tool, Miro, because now I cluster everything so far that I'm collecting, like little snippets. I'm collecting all these things, and I can link out to them. So that's really really powerful. Okay, so let's watch this video. Let's watch this video now and start learning systems thinking for newcomers, because that's what I am. Lifelong learner, always learning. Let's check it out, right? And then this video is about meta learning, so we're gonna learn how to learn. Let's see what we learn. Oh, well, the method I'm gonna do is watch the video, look for insights that I don't already know, which are gonna be lots. I'm gonna take screenshots of his. Well, I'll do it right now. Take screenshots of this video. Then I drag them over here. We're going to start a new canvas or so as you see what I'm doing here, when I screenshot this and now I'm going to watch the video, I'm going to look for things. I can pull out little sticky notes. That's obviously too big. So I make this bigger. And I can capture notes of what I'm thinking while I'm watching the video. So it's important that if I just, well, yeah, the point of the meta learning part here is that if I just watch the video, I don't retain the information. I capture some of it sometimes and write it on my whiteboard. But what I've learned over the last 5 years, and even with all the books I read, like I can't, the human memory is not capable of storing all the information that you're excited about long term. It just can't do it. So unless you apply it, unless you use it over and over and over and over, from my experience, this is what I've learned, anyways. So what I want to do now is I want to increase my ability to retain the information that I'm most interested about. Um, so that means I'm going to apply some of it. Meaning, if I get an insight from Derek, I'm going to capture it here, and at the end, I can synthesize it and maybe think about it differently and capture it and sort of mold it, like play with it, right? Like it's not just being a passive consumer of it. It's like, oh, that's an insight. I'm going to capture it. Why do I think that's cool? Well, by the time I'm done the video, I'll see a whole bunch of things that I thought were interesting. Which ones are interesting in my life right now, right? So then I'll go ahead and think about ways of applying this to my career, my family, my future ambition, right? I want to apply this wisdom to the future, not just passively consume it. Okay. All right. Let's go into it then.
So we'll get started. There'll probably be quite a number of people coming and joining as we get started. But thanks for being here today, and we will record this and post it later. Um, it's great to see so many signups and attendees who are new to systems thinking. This event actually started as a result of a post on Systems Thinking Daily by Deirdre Clark, where she said, I think her post was, anyone here that's new to systems thinking, I'd love to find a learning partner. So I want to encourage you to look around, and there are many learning partners to choose from. Feel free to message each other or whatever. It's a great way to dive into something together. And as you'll see, Laura and I are committed, and our lab is committed, especially not just to doing basic research and innovation and systems thinking, but we're especially committed to making it accessible and also high fidelity for newcomers. So this is really one of the things that we focus on a lot is making it accessible to newcomers and making systems thinking quickly assimilatable and understandable, and making it so people can get value out of it right away. So today I was going to just give a short talk, a summary of some of the things I share with our graduate students at Cornell, with first grade through 12th grade teachers, with CEOs and business leaders around the world, with leaders in private and public sectors, with parents, with 5-year-olds and 10-year-olds and 95-year-olds. Anyone can learn systems thinking, and anyone can use systems thinking. So please feel free to interrupt me at any time. This is really an informal thing. And ask a question or make a statement, or if you don't want to do that, you can write it in text, and I'll try to remember to look over at the text and answer. And after the summary, we'll do a cool activity that will hopefully help you to practice systems thinking and see the benefits of it right away. So with that,
And I will skip through. We're not going to do this for a whole hour. I'm going to scrub through the video.
we are ready to dive in, and we'll start with just a quick introduction to our lab, a little background. Our lab, Laura and I lead our research lab, and we focus on 3 areas: basic research, like I said.
So I'm going to take a screenshot of this because I love visuals. I'm a visual learner. I'm gonna take a screenshot, bring it to my board.
In cognition and complexity. We also focus a lot on innovating things like tools. So we've developed software, we've developed blocks, we've developed lots of different tools, and we research those tools because obviously doing systems thinking well, just like a carpenter or any other person, tools are super helpful. So we actually develop and innovate new tools. And then our third kind of main focus is actually public understanding, which is what we're doing here is making sure that people understand the science, that the science is accessible, that you can use it with high fidelity and all that kind of stuff. So we're really interested in those kinds of things, and we have 4 focus areas: systems thinking, systems mapping, which is visualizing it, systems leadership, which is how it.
This is my area of interest right now because I love this tool Miro, and it's been allowing me to map a lot of interests that I want to learn, and then I save them as different Miro boards. So I have one about I have many boards, but I can now cluster them, and so this systems mapping is what I'm doing in Miro, and it's the only tool I'm willing to pay for. I don't really pay for anything really, except for clothing and coffee. But Miro was worth the price, and I would pay for Derek's wisdom as well. But thankfully, he put this one out on YouTube for free. But so Miro is a mapping tool that I'm using for systems mapping. So this is where I really am excited about this video, is I'm going to start taking away not only my interest in systems thinking, but how to apply it, because I believe once I start mapping it and applying it, that is going to be like the next step, the big jump to going, okay, you're applying it, then you're learning it, right? I believe that I can learn it by applying it and get better at it. Okay, let's get back to the video.
Plays out in organizations and leadership and stuff like that, and system science, which is kind of how it plays out in nature in the real world.
I like that too.
So today we're mostly going to talk about systems.
And I think about this as a biomimicry perspective, which is using nature, looking at nature for patterns to solve your own problems. So I like that space as well. The complexity. I really like that nature has beautiful patterns that you see play out at different scales, and systems mapping. So those are the two that I'm really interested in from this video. And he breaks it down from here because it all starts with thinking before you can get there. So let's continue from there.
Systems thinking, and we'll dive into that. And we're going to try to answer four fundamental questions. Why do we do systems thinking in the first place? What is it? That's the one that most people want to know. How do you do it? You know, how do you actually practice it? And how do you apply systems thinking to your life or your work, that type of thing. So we're going to hit on hopefully all four of those things. Um, Prior to becoming, oh, there's Deirdre. It's great to see you, Deirdre. Deirdre's the reason this whole thing happened. So I'm glad that you posted that, and I'm glad that you're sort of hosting this in a way. Thanks for being here. Prior to, yeah, sorry. You want to say anything?
Nope, I'm just, thank you.
Um,
Here's an interesting thing that I'm going to change, or not change. So there's an interesting thing here I can do with visual. Take a screenshot of that thing and turn it, because why not, right? Like, I have to turn my head to read those words. If I drop this in Miro, let's see what happens. Not rocket science, but it's going to be a different perspective, a cool way to look at this. So I'm going to do this. Watch. Boom. So you live in a VUCA world, which is you live in a ambiguous, complex, uncertain, volatile world. Okay, let's get back in here.
those kinds of all the systems that altitude mountains in the world. And I tell you that because I learned most of what I know about systems being in the mountains, being in a tent 250 days, 230 days a year, being on the tent in the side of the mountain, and watching the climatological systems, the geological systems, the physics, the chemistry of the body, the physics and mountain rescue systems, and all the systems that happen as a result of mountaineering. And the mountains are a great metaphor for life. In the mountains, things are VUCA. They're volatile, uncertain, complex, and ambiguous. And VUCA is a term that was actually coined by the military, but today it's used in the private sector in lots of different places. And I don't need to tell you much about VUCA because you live in a VUCA world every day. Your jobs are VUCA, your organizations are VUCA. You know, if you have kids and dogs, your families are VUCA, and that's you know, COVID is VUCA, all of it's VUCA. So you guys know VUCA like you're experts in VUCA. But the real world is VUCA. Real world systems are probably the best way we can generally describe them is that they're VUCA. They're volatile, they're uncertain, they're complex, and they're often ambiguous. And that's not really the problem. That's just the reality that we have to deal with. So that's the world. The problem is that, and this is kind of a technical term, our thinking tends to be, and for 2,500 years has been, what I like to call LAMO. And LAMO is linear, anthropocentric, which means kind of human-centered. We sort of imagine the world being centered around us, mechanistic, and ordered. And the mismatch between those two things is really the problem. So systems thinking is trying to solve that. That's kind of the why of systems thinking. So let me just give you a few examples of the real world.
So a lot of good stuff was there. I have to back that up, and this is what I like about watching video, because now I can, if I was watching that in real time, there's no way I'd be able to capture all those notes. So I like watching videos post recorded, and then I can pause and rewind them. So he said a lot of good stuff in here. I'm going to go back again.
VUCA, and that's you know, COVID is VUCA, all of it's VUCA. So you guys know VUCA like you're experts in VUCA. But the real world is VUCA. Real world systems are probably the best way we can generally describe them is that they're VUCA. They're volatile, they're uncertain, they're complex, and they're often ambiguous. And that's not really the problem. That's just the reality that we have to deal with. So that's the world. The problem is that, and this is kind of a technical term, our thinking tends to be, and for 2,500 years has been, what I like to call lame-o. And lame-o is
It's lame.
anthropocentric, which means kind of
We're
human-centered.
lame.
We sort of imagine the world being centered around us, mechanistic and ordered. And the mismatch between those two things is really the problem. So systems thinking is trying to solve that.
Oh, that's cool.
That's kind of the why of systems thinking. So let me just give you a few examples. The real world is dynamic, it's adaptive, it's organic, and it's constantly evolving. Yet we tend to think very mechanistically. We tend to think almost like everything's a machine and it's very simple and stuff like that. We use even metaphors like the universe is like a clock or the brain is like a computer, which are not true. The universe is nothing like a clock, and the brain is really nothing like a computer. The brain is kind of a mushy, very dynamical thing, and computers, very different, right? If you look at a computer and a brain. So the real world is multivalent by nature. Now that's just a big word that means it can be and both, right? And both can be true rather than either or. Our thinking tends to be kind of needlessly bivalent, which means either or. And let me just give you an example of what I mean by this, a real world example. Do your customers want your product to be faster or cheaper?
Both.
That's
Yes.
exactly, right? They want both. So we live in a world where it's not either or, it's and both. And a lot of things are and both, right? There's good and bad, and there's bad and good, and the worst things that have happened to your life are sometimes some of the best things, and the best things sometimes turn out to be some of the worst things, and all kinds of things. So the world is sort of like that. The real world is networked and nested and complex. It even has a sprinkling of randomness in it, which makes things very, very difficult to track. Yet we tend to think of things in ordered and static categories and hierarchies, right? So that doesn't really work out very well. There's a big mismatch there. And the real world is nonlinear. It includes lots of feedback cycles. It includes webs of causality rather than, in the real world, there's no single cause. There's webs of causality. But we tend to think, X causes Y, and that's it. That's kind of just a basic causality. But in the real world, 28 different things cause something to happen. Yet we tend to think in these very linear causal ways. And finally, the real world is agnostic about humans.
So what I'm
Really, in the whole scheme of things, doesn't.
what I'm trying to do here is hold a thought, right? So I like this image without the context, and now I love the context, but I don't want to write sticky notes for everything right now anyways, because I can come back to that later. But I do like holding this thought, which is like, look at this look at this spectrum without the context that he layered in, but then adding a visual after with the context so that I can review this later, but get the big picture, huge divide, high level view of the polarity between these two concepts, and then those concepts explained. So I do like what I'm getting at here is I could have took a screenshot of I could have just taken a screenshot of this, and then when I come back maybe a month later or something and look at this, I might forget that he paused. He gave space between there when he really wanted to amplify this point, right? So if I only took this screenshot and waited and captured those notes, then I would have lost that point he made before. So that's why I'm just adding 2 screenshots.
Care. We think COVID's trying to kill us. COVID's not trying to kill us. It's just doing its thing. We think that, we're the center of the universe. We literally in the beginning thought we were the center of the universe. Then we, figured out the sun was the center, and then we figured out, boy, the universe is a lot bigger than our galaxy, and our galaxy isn't even in the center. All that kind of stuff. And we go through our day thinking most of the time that we're kind of at the center. But the real world doesn't really think that way. It doesn't really operate that way. And so that gets in our way. That causes a lot of bias. So systems thinking is really about how the real world is and how we think about it. And hopefully the way we think about it kind of aligns better, not perfectly, but better with the way the real world is. So if we can get rid of this lame-o thinking and replace it with something, that's systems thinking. And what we're going to show you today is a thing called BSRP, which is they're kind of the universal patterns that
And I guess what I'll drive towards after this video, when I go and do the meta learning, meaning I'm going to go back and look at the video, I'm going to try and put this into my own words. So I'm going to learn his framework, and then I'm going to model it differently using different metaphors and different explanations. And then that way, when I tell the story later to somebody else, my children or somebody else I work with, that this is my perspective of systems thinking, I'll be able to have my own version of it, not a replica of Derek's, right? I'll take his wisdom and then remix it with my worldview and shape it into a story that makes sense, that's easy for me to talk about. So now I'm getting excited about coming back to the data after, back to this board that's starting to grow, right? We're starting out. We're very early. I talked about what I was getting excited about, systems mapping. So I'm really interested in this because I'm a visual learner. And let me just highlight that. Whoops. And we'll bring down the opacity on this. This is another reason why I like Miro. I can call out certain things that I want to draw attention to later. I'll take off that. So here, I'm interested in this. I'm interested in this. Off the bat. This was a new concept to me, brand new. I never really learned that before, so that's exciting. And I can't wait to come back. And what I can do with this is start to drop in my own metaphors to talk about the same concepts. So I'll just do a quick example here. Some screenshots I actually have on my desktop. I'm going to drop them over here. And I'll start building out a story, a way to describe systems thinking from a different perspective or different screenshots. So these are Jack Butcher's visualizations that are absolutely brilliant. So he takes ideas and simplifies them into very beautiful, simple ways of looking at something. And what I love about these ones here is why I've captured them is, well, because what I've learned from Derek, that perspective is you only have one perspective on something. It's not the entire truth. This one is trying to explain that same thing, right? You only have one point of view that, there might be also alternate points of view coming that were shown to you. You just didn't see it all. You took your own perspective and you've only seen this one part of something, although there's more truth. So those are Jack Butcher's visualizations. I can use them and just credit him to say, like, look, this is brilliance. It's another way to describe something, but I also add my own unique way to do that. Like, this is like going through the internet and finding visuals to describe my thinking. And I'll do that again. I'll find the way of finding the right images to tell a story the same way that Derek's doing right now.
Why what we mean when we talk about systems thinking. And basically, it's that our mental models are constantly adapting and evolving, and we make distinctions, we make systems, part-whole organizing systems, We make relationships and we take perspectives, and that's it. It's very simple, but we can mix and match those things in very, very, very complex ways to do very complex things. So if you actually look at the work,
And there he talked about the framework, right, that I got my kids to learn right now because our education system is broken. So the tutor we have with my children right now are teaching they're teaching them a framework to have a mental model like he just described. Give them something concrete that they can build off of
words,
and work with rather than rote learning and trying to memorize everything. Give them tools in their cognitive capability to understand the complexity of the world as they grow.
systems thinking. The secret to systems thinking is in the title, believe it or not. And that is that the systems part of systems thinking is referring to all those VUCA systems in the real world. And the thinking part of systems thinking is referring to all the mental models that you create about those systems. And those systems could be anything. They could be, your job, your product, your practice, what you're trying to get done in the world, your family, how to make something better, all that kind of stuff. It doesn't really matter what part of the world you're looking at. So that gets us to one of the most fundamental, most important things in systems thinking. It's kind of the core of what systems thinking is, and we call it the systems thinking loop. And all it is that our mental models are interacting with the real world, and then the real world is doing something with our mental models. And so let's first dive into what a mental model is, because mental models are at the crux. They're kind of the crux of systems thinking. So I want to show you this quick video.
Mental models are a
that
jig.
I think is one of the best videos for understanding mental
Ooh.
models, because a lot of people think mental models is like framework, but actually mental models are happening all the time.
I think he says
You
they're a
guys see that
jig.
right here in this video.
I think he describes them as a jig. This is funny. The power of this medium to convey information is awesome, right? Using video to convey a complex story is just so much, it's just faster. You can convey so much information here by showing a video rather than trying to explain it.
That's a great example of systems thinking and mental models.
So maybe I'm going to capture a note of that let me back it up. That after I want to actually make little video clips to describe systems thinking from my point of view and what videos can I find. So I want to hold on to that thought. And I'm going to make note of it, right? Like do this so that don't forget, like you got inspired by this. So drop a note. This is the meta learning part where I'll come back and say, oh, okay, make
So that's a great example
your
of systems thinking and mental models, right? And what you
make your own video of how I would describe. Well, it doesn't have to be entirely systems, but I'll just put that for now. The point I'm trying to make is that video conveys more information than just screenshots. Convey more information than just a screenshot. That's what I wanted to say.
you can see is that it's happening all the time. Sometimes they're right, sometimes they're wrong. And reality is just being reality, right? The alligator was never a log. The alligator was always an alligator. But we had different mental models of what it was, and then there's even, at the end, there's this possibility of learning occurring.
Yes.
And the new guy comes on the scene and he picks the same thing, and then presumably you have another disagreement, and it keeps going on and on.
So that's a good. This is what I did at work with my team this week. Is we watched user testing videos. My perspective of how I seen the results of the user testing videos is only one perspective, one point of view, one perception of what the UX lens seen, right? Like what I observed was only my point of view. So I had another team, a colleague of mine who is in activation and marketing. He took away different insights from the video. So by us both watching the video, we were able to talk about what we seen together, which is really cool. It's really important when you see this, when people see this for the first time, that they have their own bias that can, it doesn't always get you into trouble, but just to know that you're biased, and that when you see somebody else's perspective that actually gives value to what you're trying to build or to better on, it's really cool when you can have when both parties or both people know that this is happening. Because a lot of people don't even know this is happening. They just think, well, I seen the video, you seen the video, we seen the same thing, which is not true. You do not see the same thing. You interpret the video from your worldview, and the outcome of that, what you've seen, is this, right? So he would have described, oh, I seen when this user test showed, or it was an interview, they described this. And I seen the video, and I took notes about this. It's a good thing we record it, because now when we watch the video back, you realize you can't capture all of the information in one live session. It's just the brain will pick up what it wants, and then that's it, right? It gets little bits and pieces, because your brain's trying to process what it's watching. But when you go and watch the video back again, you can stop, pause, rewind, and go, oh, I totally missed that, or I forgot. Like in one day, you got so much workload that it's nice to go back on it and pick up things that you didn't know you forgot, right? And that might improve the product you're working on. Let's go ahead.
But this really gets us to the crux of systems thinking, which is that this quote that kind of captures what systems thinking is all about, why we do it, which is that wicked problems, are the problems that we have, result from the mismatch between how the real world systems work and how we think they work. So if we can change our thinking.
So I do what he just described there in product design, right? There's a mismatch when we build products of what we're trying to build, right? And if we say it has to be client-centric or customer-centric or user-focused, user-centered, basically we're trying to say it's this person that uses the tool. How do they use the tool, right? How do you use a pen? Watch somebody use it. Some people describe the person uses it this way. Some people use it as a fidget device, like a fidget spinner. They don't actually write anything down. Some people do this all day. But we use things differently, and people need to capture all that information so that we have different points of view on product design, not just one person saying this is how it is and let's build this feature. So I like this part of the video. It's relatable to my how I can use this information. I can take this capability, this method of system thinking, and bring it into conversations with people I work with, and then educate them that we're going to get to a better result if we take this approach rather than the old approach, which is thinking this is not an alligator, this is a log, and then somebody gets eaten.
To be more in alignment with how real world systems work, then when we do things, when we execute certain plans, those plans will have a higher probability of working. So let me give you a little more examples of what we mean by mental models and having them work or not work or be in alignment. This is a great mental model of how we think an organizational system works, right? It's called an org chart. We say, this is how our organization works.
That's not how it works at all.
They report to those people report to them, and then down
I got experience working in this space, trying to understand the complexity of an organization you're in is weird in a sense that on paper it looks so structured when in reality it's like this person does not know what the fuck this person's doing. They don't know what they're doing. Nobody knows what the fuck's going on really half the time. It's hilarious.
And it's really a great thing, and it's very popular. Every organization has one because it's really simple, it's easy to understand, and that kind of thing. But the truth is that the organization doesn't work at all like that. The organization works probably more something like this.
Ha, I haven't watched this video yet. So I didn't see that coming, but that is more accurate.
Which is that there's a lot of nonlinear relationships going on, non-hierarchical. While there is some formal reporting structure, there's also a lot of informal relationships. Influence is not always situated in the hierarchy. Influence could be caused by nonlinear, asymmetrical relationships, or those kinds of things. So it's a lot more complex.
This is brilliant. Kids at same school sells drugs. Threesome. Oh, this is brilliant, Derek. I gotta use this. This is really good. This is brilliant.
And a lot more dynamic than our first mental model was. And if we treat our organization like that first mental model, then when we press the buttons that we think we should press, we're not going to get the results we think we should get. So that means that our mental models, that all of our mental models that we're having all the time about something are always just approximations of the real world, of real world systems. What that means is that our mental models are actually always wrong to some degree. And in fact, the great statistician George Box said, all mental models are wrong, but some are useful.
I like that.
Right? So all of our mental models.
I like that. I when I hear that, I love hearing that every time, because we get so attached to our models. Like in flipping COVID times right now, you have people thinking that these models are true, and it's just the best, maybe not even the best information right now, because a lot of it's garbage in, garbage out. But the models that are being perpetuated through the media and government, there's a whole lot of fear mongering going on, because everybody just believes these models without understanding that it's highly complex. Okay, I want to back that up a second because I want to capture that note.
Then when we press the buttons that we think we should press, we're not going to get the results we think we should get. So that means that our mental models, that all of our mental models that we're having all the time about something are always just approximations of the real world, of real world systems. What that means is that our mental models are actually always wrong to some degree. And in fact, the great statistician George Box said, all mental models are wrong, but some are useful. Right? So all of our mental models.
And that is the brilliant quote.
And in fact, the great statistician George Box said, all mental models are wrong, but some are useful.
See, I had that worded differently until I replayed it, captured it correctly. Because the brain, well, at least mine, cannot keep up when I'm trying to absorb insights and capture them at the same time. But this quote is probably going to have great visuals, so I'm just going to jump over here real quick. Watch, we'll go to images and watch, we'll catch the guy that said it. And we'll give him some credit here. Right, let's give this brother some credit. Let's copy this image. And we'll come back to Miro, watch this, paste. Boom. Now you go down, now you start opening up rabbit holes when you're like, oh, who's this guy? right? Somebody who says something as brilliant as this and it stands the test of time is Lindy. And when a guy like Derek is saying, you know, using a quote like this, you can say, whoops, fuck off. What else? What other wisdom can come from this guy? So you go to Wikipedia. Where is he? George Box. Is it George Box? Is that who we said? Yeah, George Box. So let's go George Box. Because I'm going to learn a little bit more about this guy later, right? George Box. There's more to this cat than meets the eye. So I'm going to copy and paste that. But I don't want to lose the momentum we're going with Derek. So what I do is say, I want to learn more about this guy. So I dropped it in Miro here. And now I can come back to this later. Right? But now I will come back to this later. And I have a direct link. So when I come back later, there's a relationship between what was said at the video here, that what I liked about it was this, and when I come back later, if I want to learn more, I just click here, boom, and I'll go learn more about Georgie. But right now I want to keep on going, so let's keep on going.
Right? So all of our mental models are wrong, but some are less wrong than others, and some are very useful. And the goal of having a mental model is to have it be a good approximation of the system that you're looking at. Now, the way you do that is you test your mental model in the real world. And importantly, you get feedback. And the goal of having a mental model is to have it be a good approximation.
Boom. The goal of a mental model is to have a good approximation. Right there. That's a big one. The goal of a mental model is to have a good approximation
Of the system that you're looking at.
of the system that you are looking at. Keyword, a good approximation. All right.
Now, the way you do that is you test your mental model in the real world. And important.
This is what I do in product design and development is everything's a theory until you put it in front of people, and you actually don't know until it's actually being used if it's useful or not.
Importantly, you get feedback from the real world.
Then you iterate.
And that feedback comes in the form of information.
Ooh, information.
So information goes back into our
I love information.
mental models, right?
Especially. This information right here. This book is insanely good. The information. James Gleick. Everything, well, our senses interpret information. So information is super fun to learn about. Maybe I'll do a learning about information, meta learning video on that. That'll be cool.
If we don't do that, then our mental models sort of stay static and they don't evolve, they don't change, and they don't get incrementally better. Right? So we want to incorporate that feedback, and we want to constantly be testing our mental models against the real world.
Sounds like product design.
Now, I want to tell you something about, and that feedback comes in the form of information. So information goes back into our mental models, right? If we don't do that, then our mental models sort of stay static and they don't evolve, they don't change, and they don't get incrementally better, right? So So we want to incorporate that feedback, and we want to constantly be testing our mental models against the real world. Now, I want to tell you something about a bias, because we have lots of bias, right? If we don't do that, then our mental models sort of stay static, and they don't evolve, they don't change, and they don't get incrementally better, right? So we want to incorporate that feedback, and we want to constantly be testing our mental models against the real world.
If we don't. What does he say there?
Right? If we don't do that, then our mental models sort of stay static, and they don't evolve, they don't change, and they don't get incrementally better.
So they get they just decay. Just mental against the real world. Well, at least stagnant's the right word. They become stagnant. How do you spell stagnant? Stagnant. Stagnant. Fuck. Stagnant. Stagnant. Here's learning how to learn. Don't know how to spell stagnant. Don't care. Learned it now. That's all we need to know. In the real world, they become stagnant. Because the world is in a constant change, so you can't become stagnant in a world that is constantly changing. Become stagnant.
Right? So we want to incorporate that feedback, and we want to constantly be testing our mental models against the real world. Now, I want to tell you something about
and stagnation is not learning, right? Stagnation is not learning. Yeah. We're doing meta learning is the vlog, a meta learning vlog to learn about systems thinking is telling us that if you're not learning, you're becoming stagnant in a world that's increasingly always changing. You have to learn. You have to learn how to learn better than our institutions are teaching our kids. You need to learn models that you can incorporate into your life that allow you to one-up yourself every single day.
bias, because we have lots of biases. In fact, I would say if we were to take the last 50 or 60...
Okay, so this image he's got here is the equivalent, not the equivalent. This one is similar to Jack Butcher's. And since it came to my mind twice, I will use it twice. I'm going to bring this one over here because why not? Like, I'm allowed to. I can have the image on here more than once. So I'm going to take it, move over here. Because what I want to say here is what he's going to describe here is the same as what Jack Butcher is trying to describe in I think a better visual here. So let's see, right? He's trying to describe your mental model is a bias. So watch this and see which visual conveys the idea. I don't want to say better, just, well, yeah, some things are conveyed better than others. But let's see.
Years of the cognitive sciences and summarize what we've learned from them, right? I would say that we knew that humans were biased. But what we've learned is that they're even more biased than we thought they were.
Okay. That's cool. He's trying to convey something different. But I actually do like his visualization now that I heard him talk about it. because what he's trying to convey is that we had a sense, well, at one point we didn't have any sense that we had this bias. We thought we knew everything, the mechanistic worldview, that we know everything. Universe is a clock, when it's not true. Now we're getting to the idea that we know less than what we think we know. So I do like this, and this is like a lens or a filter of reality through this point of view. So actually this does a really good job, because he's trying to convey something else, not what Jack was trying to convey, which is just basically that you're biased. And this is a good visual to show, if you didn't know that you have bias, that it's out there. And once you get this, you get it, right? Which is awesome, where he's trying to convey, look, at one point we don't know we're biased. So this is the same as what Jack's trying to convey, right? This is the same as what Jack's trying to convey, right? There's like, you know, the unaware. If you're unaware that you're biased, you're really not seeing the whole picture. Where this one is a different, this one is like, you actually know less than what you think you know. Well, that's interesting.
And by humans, I mean all of us, right? So what cognitive science has really taught us in the last 50 years is that we're actually way, way more biased than we thought we were, and we thought we were pretty biased. Yeah? And so I want to tell you about some of the biggest biases there is. This one I call reality bias. It's kind of the grandfather or grandmother of all biases. And it's the
Whoops.
belief that we see the world directly as it is, like on the left, right? We see the world directly as it is, with no awareness of the veil that we're shrouded in. And that veil is our mental models. And we're always looking through that veil.
So you are a reality bias. This is interesting. I could probably do a meme on that, because this is such a topic right now. What are we at? Oh, it dropped a bit. I'm going to take my old little Bitcoin image, copy, paste. Whoops. Let's try and make this into a meme, a real-time meme for all the rage that's going on right now. So you got your Bitcoin and you got your fiat money. Well, it's really gold is the replacement, which is a store of value. So what if I just said a fiat coin? Okay, I'm going off on a tangent here, but whatever. You could say this. Yeah, this idea. That's what what I really want to meme here is that there's a fiat system that people are holding on to. There's a fiat world that people are holding on to that is literally changing right beneath their feet, and they don't even know it. So I want to copy this image. I already copied that one. I'm going to paste this. So here's what I think is going on from my distorted, biased reality view. And I could be wrong, but what I'm getting at here is this, right? Like, it's like reality, fiat, the new reality that's emerging, right? It's boom. Take a screenshot and watch. Take a screenshot of this, drop it up over on the old Twitter tubes, tag Derek, right? You unaware of reality bias, Fiat is the only thing. Your mental model of reality. So there's some Bitcoin behind there. I guess this is a bleed between probably half fiat, half Bitcoin. But eventually it's like, boom. There's this other world emerging that is not everybody is aware is happening. It's almost under the surface, but something's happening there. We'll see. I'm tweeting that out because that's just going to be fun. And I'm going to copy this because I just had to play. And that's what, some of this stuff is just about playing around. We were just having some fun there. Memeing is all about having fun. If you can't have fun, then what the fuck are you really doing? Right? Okay, so we're going to go over to the Twitter sphere. And we're going to go drop this in here. We're going to tag Derek, see what he does. Derek, I know you're in here. It's Derek. Somewhere in there. Derek. No, there's no C. There he is, Derek. Should I tag him there or in here? I'm going to tag him here. I'll put a emoji because it's a joke, so you have to convey that this is a joke. Come on, the fuck, put it in. Okay, I'm losing. Oh, okay, there we go. Ha 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 ha. That's a joke, Derek. Hope you can get it's a joke. They had to remix one of your slides. Great video, by the way. Great video, by the way. I'm halfway done. I guess I can tag him here because I'm talking to him now. Get great, GRE. Great video, by the way. I'm halfway done. Thanks for putting it out there for us to learn. See if he gets that. Okay. There's Jack Butcher. The man, the legend. Okay, back to reality. All right, let's go. Back to reality. Here we go.
The truth is,
And that's how creativity can take you on a tangent, and you got to capture and play with creativity when you get it. It's not always there, and that's part of learning. It makes learning fun.
see the world indirectly, mediated through our mental models. That is mind-blowing if you think about it. We don't experience the world directly, we experience the world indirectly through our mental models. So the thing that we have to really work with, the thing that we have to work with, not only have to work with, but must work with, need to work with, is our mental models, mediated through directly directly as it is, like on the left.
Okay. Now we're going to get meta. I'm going to shoot a little video, try and get a quick video of me watching him talk about this while I'm live. Well, I got to reverse it. I'll press play and we got him talking about it. Well, where is he? Yeah, he's there. So let's get on to that. This is meta.
Right? We see the world directly as it is, with no awareness of the veil that we're shrouded in. And that veil is our mental models, and we're always looking through that veil. The truth is, we see the world indirectly, mediated.
So let's play that back, right? Because right now this is running live. Let's see if it's big enough. It might be too big to share. Where's the volume?
Is our mental models, and we're always looking through that veil.
Yeah. Let's see if I can share that. Share that on Twitter. Well, yeah. Okay. What do I tag it as? Meta learning. Yeah, that's what I'm going to tag it as. Meta learning. It is meta learning vlog. I don't like that word, but it's what it is. Meta learning vlog on SY systems. I'm going to use systems thinking as a tag. Okay. On. Because this is meta. Systems thinking. Systems thinking. Meta learning vlog on systems thinking. Tweet that. That's going to take a bit because it's a video. Right? But that'll be funny.
Through our mental models. That is mind-blowing if you think about it. We don't experience the world directly, we experience the world indirectly through our mental models. So the thing that we have to really work with, the thing that we have to work with, not only have to work with, but must work with, need to work with, is our mental models. Now I want to show you this. This is one of my favorite cartoons, right? It says, "Say, what's that mountain goat doing up here in the clouds?" Right? What we have to understand is that this is a great cartoon that captures another bias called confirmation bias. One of the most pervasive biases that we face is confirmation bias. And that causes us to filter real world information and fit it to our mental model, rather than to fit our mental model to the real world. I want you to say that over again in your mind.
That's hard.
Confirmation bias is just getting the loop going in the other direction. So we fit the real world to our mental model rather than fitting our mental model to the real world. I want you to say that over again in your mind. Confirmation bias is just getting the loop going in the other direction. So we fit the real world to our mental model rather than fitting our mental model
This is a tough one. This is what I might ask Derek to help me understand more, because if the world is only a model of our what we can think of, then how can you possibly fit the real world into a mental model? That one's tricky.
To the real world. That's critically important. So if you could have your mental model in your real world and get the loop going the wrong way, and you've got a whole lot of confirmation bias.
I want a different example of this. And he's using this picture to describe it. What's that mountain goat doing way up here in the cloud bank? Oh. Using the fit the real world into our mental model. Oh. The real world is that goat's on a mountain. And he's fitting that into a mental model that he's in the clouds. And they're not. They're heading right for the mountain. I wonder if there's another analogy we can use how we do this other than a pilot. There's got to be a different metaphor. Because I'd like to really go into that one a little bit more, but I'll take a screenshot of this so I can capture that.
Or you can get it going the right way, and you've got a whole lot of learning.
A whole lot of learning sounds good. So get it the right way, get a whole lot of learning. Which sounds like an iteration cycle in product design is how I usually use it. Get the loop going. It's really getting out of your own head, right? It's observing what you're thinking is and what you're doing in the real world. How's the real world reacting to that? How are you measuring those responses to your hypothesis? Get the loop going the right way, and you get a whole lot of learning. Come back to that. I want a different metaphor for this. So I'll put a little comment on this. I want different metaphor of this bias.
Very, very important.
Okay, how long are we running on this video now?
That leads us to sort of complete the
Fuck,
model.
no idea. Yeah, iteration. Yeah, you gotta iterate. That's what product design is all about. Iterate. Learn from the field, bring it back, put it back in the product, test again, learn. Without you making it up in your own head.
Approximating by testing. We're constantly incorporating feedback in the form of information, and we iterate going round and round, or we make sure that we're going in the right direction. So iterate, approximation, information, iteration of mental models and the real world. And this is the crux of systems thinking.
Beautiful.
It's the crux of systems thinking. It's
Beautiful.
also the crux of human learning, science as an endeavor. You could change the terms a little bit. You get evolution as a theory. There's lots of things going on here. Design thinking is based on this loop.
This is brilliant. Let's back that up so we get that again.
Very, very important, confirmation bias. So that leads us to sort of complete the model, which is that we're constantly approximating by testing. We're constantly incorporating feedback in the
Fuck.
sort of complete the model, which is that we're constantly approximating by testing. We're constantly incorporating feedback in the form of information.
This is the same as information foraging theory. And the CRT, no, CRT. I'm going to have to look that up in 1 second. And I'm just going to say that this map is similar to information foraging theory, THE theory, which stems from optimal forage theory, and that is animals foraging for food. I believe it's optimal foraging theory, and then we use that model to describe information foraging theory, which is very similar to what he's describing here. So I want to put those models side by side and look at them. Came back too far there, right here.
Approximating by testing. We're constantly incorporating feedback in the form of information.
What did he say there?
Leads us to sort of complete the model, which is that we're constantly approximating by testing. We're constantly incorporating.
It's because he stumbles, but we're constantly incorporating
Feedback in the form of information.
We're constantly incorporating feedback in the form of information.
And we iterate going round and
information, and then the iteration is self-evident. So we run a test. That's an animal foraging for food, exhibiting patch foraging behavior. Let's say a fucking bear trying to get berries out of a bush. It will go to that bush if it's got berries, and then if it runs out, it's trying to find out the next path of a bush that has berries. And then it might see one or two that might look like they appear to have more. How long do they stay at one versus going to the other? It's really not a test. I'm trying to conflate the test here with animal foraging theory. It's too big of a stretch here. And I don't want to just keep using product design. I want to have a different way to think about it. And we're constantly incorporating feedback in the form of information. But I get what he's getting at. I'm just going to pull out this map where I have that information foraging theory. Information. It's the ACTR. That's what it is. It's the ACTR framework. ACTR framework is the same thing. It's how the cognitive mind works. How thoughts work. Where's a good map? I have a different visual on a Miro board, but I don't want to go digging right now for that, so I want to use a different one that's just a quick little image. Let's see. Visual model, environment. Like there's a loop. Yeah, pattern matching. No, it's not what I want. Subject, Actar, nope. Oh, this one. Declarative memory, production memory, and working memory. Outside world, retrieval storage. There's a loop of observation. Um, so information foraging theory has a model about how we think. Adaptive control of thought model. Actar cognitive architecture. Yeah, I'm just going to drop this one here because this is what I'm trying to get at. So I'm going to copy that image, and that is related to what's happening here, which is also related to animal optimal foraging theory, right? Which is optimal foraging theory. Optimal foraging theory. Behavior and ecology model that helps predict how an animal behaves when searching for food. There's got to be a good image of that because these are all related. This pattern, I love this pattern. Here's one, let's see. Resources, oxygen, glucose, prediction risk, foraging, move or move not. Oh, that's good. Copy that image because this is what these things are doing here. And they're layers of the same pattern. Let's see if there's a different visual. Just I don't have another one, but that's okay. That's good enough for now. That's good enough for now. Learning curve. This is good too. It doesn't always have to be visual, but I do like them. Let's say copy this. Copy this. Put that in with this one. Right, so optimal foraging theory. Organisms forage in a way that maximizes energy intake per unit of time. No, slow down. Organisms forage in a way that maximizes energy intake per unit of time. Most calories in the least amount of time. Yeah, so the bear looking at the bush, seeing lots of bushes with more berries. There's no point of going to another one if there's tons in this bush because it's going to waste more calories going to the other bush looking for more berries. So he's just going to eat the fuck out of the bush that has the berries right in front of him. Okay, and like I have a chicken coop in the back, and we had a coyote, no, or a fox, one or the other. I can't remember what it was now, but I have that thing secured like Fort Knox, so it's gonna smell the chickens, come around, try to get in the coop, realize it can't, and fuck off because he has better odds of being a wild animal and finding some squirrels or something else than get my chickens. So there's a trade-off they're making between the energy that they have and that they're going to gain by going to get the food. And I love this natural pattern because it's a natural system. It was evolution designed by whoever created us, whatever created us, whatever we are. Maximizes fitness, minimizes energy exerted. And there is a way to do some equations on this. Average, I don't know how to fucking do this. Maybe I'll learn this someday. Energy, handling time, search time. But that goes into these similar patterns of how our brains function. How we model the world.
We make sure that we're going in the right direction. So approximation, information, iteration of mental models the crux of systems thinking. It's also the crux of human learning, science as an endeavor.
It's also the crux of human learning, which is this. This is how we learn, right? How your brain works. Science. What else does he say?
You could change the terms a little bit and you get evolution.
Evolution, which is, optimal foraging theory. This behavior has been around forever to keep reproducing.
As a theory, there's lots of things going on here. Design thinking is based on this loop. All of this.
And I'm in the design world as a career. But that's surface level, easy to do product. This is why I like systems thinking and getting down to this level of understanding what systems thinking really is understanding that there's a pattern, there's a repeatable pattern that's happening in nature about understanding how not to waste time when you're trying to learn, right? Learning how to get food, learning how to learn to get food or get a career or get what you want out of life. I'm really glad I did my first show on systems thinking, because this show is going to be about meta learning, and I want to learn about lots of things. Systems thinking is the first one that I really want to play back, right? So this video will be the first, and then I'm going to try and break it down to say, okay, I watched Derek's Cabrera's video on systems thinking for newcomers, and here's what I took away, and then try to synthesize it and say it back so that I can comprehend what I took away, what I thought was interesting, my own notes. Had some fun, dropped some memes out there into the Twitter sphere. What really excited me, where, you can start to see from capturing this video what got me excited, right? So we started off very slow, we're at introduction, okay, but then once we hit on a few topics, it's like the brain gets fired up. It's like, oh, okay, this part I'm thinking about, when he's talking about this, some other thing I have in mind, which is Jack Butcher's work on simplifying what it means to think about biases, right? So lit up there, adding more screenshots. Love this quote. Going to come back to that later. You start to see sticky notes are bigger here. Why? I'm going to go, why did I make sticky notes bigger here? Had some fun here. And then right here, it's like, okay, that part of the video really, really sunk home. There was a lot of relationships to the information being conveyed. So right now, we're getting a bit of a map into parts of the video that excited me. So let's keep going.
Big human sort of iterative.
And then I did some meta sharing. So let's see where that's at. And oh, look, here's Jack Butcher's fucking Chrome plugin, right? Go up to your Chrome plugins. I don't know where mine is. Extensions, yeah. Visualize value. Go get yourself visualize value. Every time you open a new tab, you're going to get one of Jack Butcher's visualizations, and they're brilliant. They're just brilliant. So anyways, I was going to go to Twitter. Let's go into Twitter. The only thing I don't like is when I go into a new tab, I used to have my bookmarks there. I don't know if I can get them back, but I love Jack's visuals, but I lost my bookmarks. So I used to have Twitter or whatever, my other things there. I would just quickly bang, bang, bang. Now I have to type into the URL bar. So now I kind of want my bookmarks back. I just wish I would get both. Jack Butcher's visuals plus my bar. Okay, no action on the tweet over at Derek. Is probably busy, which is fine. But let's just show that meme, because that's what else we did today, which was funny. Oh, the video went up. Meta learning on vlog. So here's Meta, because this is live. You're watching a video live of me learning live. Get that? Yeah. That's funny. So let's see.
We see the world directly as it is, with no awareness of the veil that we're shrouded in. And that veil
So we're live. I posted live me learning about reality bias, made a meme, fired it out on Twitter, and now it's up there. And that's a loop. Next. Having some fun here, folks.
Things are based on this loop. So it's a pretty important idea. Okay, so we incorporate, I want to hit on another idea that's very, very popular in systems thinking, and maybe you've seen it before, but we'll go through it. And that is that we call it the iceberg. And that is that let's pretend you're the boat, or maybe your organization is the boat, and hopefully the boat isn't the Titanic, right? But the systems thinking iceberg gives us insight into why we should focus on mental models. So you may have seen this idea, and the top of the iceberg, what's seen by the boat, is what we call events. So that's like, the information, the ideas, the content, the details of what happened, right? But what we know in systems thinking, what systems thinking tries to get us to do, is look a little beneath the surface and see the unseen. And if we look beneath the surface, we see there's a lot more beneath the surface. So we see more. And one of the first things we want to see is what's called patterns, right? And the reason we want to see patterns is because patterns allow us to predict, right? And a pattern is just an event that's repeated.
Interesting. So he's going on about patterns. I'm dropping in a screenshot. We just talked about patterns, how I'm finding this pattern of a system thinking process, how he described that. I've seen that pattern before in how the model of our thinking works, and in optimal foraging theory. So this is a pattern that's I've seen, and he's talking about patterns. So this is cool. So this is leading into this really, really nicely, that once you see patterns, you start seeing them everywhere.
Something repeated. So 2 is the smallest pattern, and then 3 and 4 just reinforces those patterns. And it gives us precious seconds or minutes or days or weeks or months or years to predict and be able to know that something's coming.
Oh yeah, yeah. And I'm just gonna add. I'm gonna drop in here. Bucky is the trim tab. We're gonna do. I love this Bucky quote. Who says, "Call me trim tab"? Whoops. Call me trim tab. Bucky Fuller. Call me trim tab. Okay. That's because Bucky is a killer systems thinker here. So, critical path, Bucky Fuller on a boat below the rudder, or with the rudder. There's a tiny rudder that can, you move it a little degree, has a huge effect on where that boat's going to go later. Call me trim tab. No, just call me trim tab. Call me trim tab. Where's Bucky? Come on. Yeah, it's on his tombstone. I didn't know that. Yeah, here it is, right? Because we're talking about this. So let's drop some of this shit in here. Copy image. On the bottom of here, you're going to have a pattern of what he's talking about, which is, something small can have a huge impact later down the line. That's a pattern, right? That's an event that's going to happen. And there's a pattern here that I'm putting in relationships between how Bucky describes this same phenomena. So let's get Bucky's tombstone out here. This guy was an absolute genius. Copy this image, because this comes from Bucky, right? Call me trim tab. And here's the trim tab. Copy. Right on the bottom of a boat. And people don't know this, but it's part of the larger rudder, and it has like slight. I believe they modify this just a slight degree, and it has a huge impact into the steering of the ship that people just aren't even aware of. They think it's one thing, one rudder, when it's all there's this like micro control, subtle control that affects the ship's direction longer down the line. Okay, so let's play this out. Let's play this out. We have a whole relationship of information here. Let's go.
Something a little deeper that we want to look for in systems thinking, and that is what's called system structures. Now, structures are really important, and this is something that I sometimes joke with my grad students that they should get tattooed on their arm. It's so important. But my wife says I shouldn't advocate that young people tattoo themselves. And it says system structure determines behavior. Now think about that for a second. What does that mean? It means that the structure of a system determines the system's behavior. And this is something that I sometimes joke with my grad students that they should get tattooed on their arm. It's so important. But my wife says I shouldn't advocate that young people tattoo themselves. And it says system structure determines behavior. Now think about that for a second. What does that mean? It means that the structure of a system, advocate that young people tattoo themselves. And it says system structure determines behavior. And I think about that for a second. What does that mean? It means that the structure of a system determines the system's behavior. Now, structures are really important, and this is something that I sometimes joke with my grad students that they should get tattooed on their arm. It's so important. But my wife says I shouldn't advocate that young people tattoo themselves. And it says system structure determines behavior. Now think about that for a second. What does that mean? It means that the structure of a system determines the system's behavior. What does that mean to you?
It means the structure of the system determines the behavior. Huh. So this whole thing is the system, the whole world, and the object in the world, and the two objects in this frame, right? So the system is the entire frame, right? The system is the environment, is the iceberg, and is the boat. All of that is the system. The structure of the system determines the system's behavior. So what that means is this boat is not, it has to respond to its environment. It cannot not respond to it, or it drives right into it, right? That's what that means. The entire structure is the system. There's relationships. So as you build boats, you have to learn that in the environment there are icebergs, and we have to have a mechanism on our boat that allows us to move around icebergs. So put a rudder on it. That will allow us to navigate around this structure in the environment. and even subtle changes if you know, well, this is going to be a stretch here, but what Bucky was trying to say with Call Me Trim Tab is that the farther out a captain of a ship can see that there is an event ahead, an iceberg, he can adjust something slightly to navigate around that obstacle. He doesn't have to do a hard turn. He can react differently farther back if he can see farther ahead by making smaller changes. I think it takes less energy to move the ship if you can see the event farther out into the horizon. It's just my guess. I don't know for sure.
That means that if you don't like the way a system's behaving, a system could be your department, your company, your family, yourself, your body, whatever. If you don't like the way it's behaving, the reason it's behaving that way is the system structure. And if you do like the way it's behaving, the reason it's behaving that way is the system structure. So you should really pay attention to system structure, because that allows you to design. Because when you know the system structure and you know the behavior, then you can sort of tweak the system structure and get different behavior. But there's one more thing that really systems thinking encourages us to go deeper and see, and that is mental models. And that's what we just talked about, is this ST loop, this systems thinking loop, and seeing your mental models. And believe it or not, a lot of people have that reality bias. They go through life and they don't even think about mental models. They think they're experiencing the world directly. But just the first step in systems thinking for newcomers is understand that there's a mental model between you and the real world. And then we start to ask questions about our mental models and how to get them to be better. So we've gone over the first big step in systems thinking, and that is this ST loop, right? Mental models, approximate, test them against the real world, get informational feedback, and then incorporate it, and then make your mental model a little better, test it again, therefore iteration. That's the first step in systems thinking. You'd be surprised how few people and few organizations actually do this. Right? You'd be surprised. Models, approximate, test them, again, seeing your mental models. And believe it or not, a lot of people have that reality bias. They go through life and they don't even think about mental models. They think they're experiencing the world directly.
Mm-hmm.
But just the first step in systems thinker for newcomers is understand that there's a mental model between you and the real world. And then we start to ask questions about our mental models and how to get them to be better. So we've gone over the first big step in systems thinking, and that is this ST loop, right? Mental models, approximate, test them against the real world, get informational feedback, and then incorporate it, and then make your mental model a little better, test it again, therefore iteration. That's the first step in systems thinking. You'd be surprised how few people and few organizations actually do this. Right? You'd be surprised. You'd be surprised how few people take their model, test it, and then get results, and then change their model a little bit, and then test it again and get results, and then change their model, fundamentally learning. You'd be surprised. There's a lot of people that have the same experience over and over and over again and never change their behavior.
Yeah, because
which means they're not doing this. So
they've been formed by a institutionalized learning system. A lot of people just thought, I'm going to get my job and it's just going to be gravy, when they don't realize that you got to learn. You can't stop.
this might seem like really basic and simple, but it's really not practiced very often. The second thing we got to do is understand that mental models are actually made up of two things. The first thing they're made up of is obvious: information. Now, where's the information coming from? Hopefully the real world, right? If you're going the right direction, the information's coming from the real world systems. So we know that mental models have information in them, but they also have something else that give them meaning, and that is how we structure that information. Because that information in and of itself doesn't have meaning. The way we structure it gives it meaning. And this is where it's really critical to understand systems thinking. So that structure is called thinking, Other words for it are cognition. That's kind of the academic or scientific term for thinking. We sometimes call it structure. We sometimes call it encoding, and sometimes we just call it organizing. The organizing of information, or encoding of information, or structuring of information, or thinking of information. It's all the same thing. Different words for the same thing. Now, what I'm going to show you today is the research on what constitutes that thinking that makes it systemic. And it turns out that there are 4 universal patterns to that thinking. And those we just call them DSRP because that's the name of the 4 patterns.
Yay.
We make distinctions, we organize systems of part whole, we make relationships between things, and we take perspectives. And when we take perspectives, the distinctions can change, and the way it's organized can change, and what's related can change. So you can see it already you can start to mix and match them to get very, very complex. And on the other side is all forms of information, content, data that comes in, right? And you structure it into a meaningful mental model, and then you test that mental model. So it's kind of a 1, 2, 3 approach.
Things are nice in threes.
At its base, systems thinking is made up of all these rules, distinction making.
I don't like rules.
You don't have to understand those right now as newcomers, but later you'll get to understand that the elements are really important. Systems are made up of parts and wholes. Relationships are made up of action and reaction, kind of like Newton's law.
But if we didn't have rules, bridges would break, planes would fall out of the sky. So I need to learn to like some rules, not all of them.
A simple way of saying this, again, just when you're new to this, it gets much, much more complex and much more robust and technical. But you can just ask these 4 simple questions. What distinctions?
And I'm recording this live, so I don't have to do the post-production of uploading it after. Not for, so that's recording it live. It allows me to just like hit, when I'm done, it just automatically uploads. So that's a cool feature. So I don't get to edit out all the shit I don't like about this video, but at least I don't have to spend any time after uploading videos.
What are the salient parts of the system? Are there relationships among the parts? And what different perspectives could I take to better understand the issue? So at the most basic level, you can just ask yourself those 4 questions, and that'll get you started.
Cool. Cool. Thank you.
There's lots more to learn around what these 4 patterns do for you, but to just get started out of the gates, just ask those 4 questions.
Okay.
And that'll get you started.
Okay. Thank you. Thank you, Derek.
So I want to give you kind of an example that's on everyone's mind, right? And that is COVID. And let's take this example of COVID and let's look at it.
Well, we're already about an hour in here, and I've gotten quite a bit of information. But yeah, he's really drilling into the complexity of this. Virus is a hoax, no mass. Virus is serious. Yeah, there's 2 polarized perspectives of this, and I'm in the middle. But the information out there is just not reliable. Just not reliable information out there. Okay, so then it goes into breakout sessions. Okay, so I'm not going to go into that part. Let's just listen to his analogy of COVID. And I want to jump in if I feel like I'm in the middle rather than on a polarized spectrum, because there's some things I agree with and some things I don't.
And that'll get you started, right? So I want to give you kind of an example that's on everyone's mind, right? And that is COVID. And let's take this example of COVID and let's look at it. COVID-19 is definitely VUCA, right? That's the reality of COVID. It's volatile, it's uncertain, it's constantly changing, and the information that we get about it is constantly changing. It's complex. There's many, many webs of causality and micro behavior and delay and macro results. And it's hard to see how the micro behavior is connected to the macro results sometimes because there's delay between them. And of course, it's ambiguous, right? There's multiple stakeholders with conflicting interests, and it makes COVID a real wicked problem.
Yeah, shut down the fucking world.
Now, we could take a ton of different perspectives on COVID, right?
Actually, it didn't shut down parts of the world.
There's a scientific perspective, there's a political, economic, social perspective. We could take the perspective of regional bubbles. We could take a mental health perspective. We could even take an anti-masker, anti-vaxxer perspective. And that might sound like
And I know it's just that term gets put into the same bucket as somebody who's a conspiracy theorist or who has a conspiracy. If somebody has a conspiracy theory, that word alone now buckets them into extremists. And to have a conspiracy theory does not mean you're an extremist. Same with anti-masker, anti-vaxxer. By putting the word anti in front of it, buckets them into an extremist category, where I would change that word to say a choice masker and a choice vaxxer. It should be a choice if somebody wants to wear a mask. It should be a choice if somebody wants to wear or get a vaccine. But by labeling them as anti is saying that they're all extremists. They're not all extremists. I get it, right? Everybody's afraid, but I also get biology and an immune system needs oxygen, and this is a very complicated topic, in that by calling it this puts those people into the extreme end of the category rather than a choice, or you know what I mean? It's just it's labeling them as extremists, and there's a spectrum there. There is a spectrum there. They're not all extremists. Some of them are. Some of them are extremists. Not denying that, but they all aren't.
not something you want to do, but you do because that perspective is changing their behavior. And their behavior is causing real things to occur in the system that you care about. So even if you disagree with a perspective, you still have to understand it because that perspective is influencing the behavior of possibly tens of thousands or millions, and then you get system-wide effects. Maybe millennials and students have a very different perspective than others. Schools, hoaxers, CDC, WHO, and then the various countries. And of course, there are many, many more perspectives that you could take that would look at the COVID pandemic differently and see different things. Let's look at the distinctions, right? Just the distinctions we make, right? We can't barely even name the thing. There's so many different names for it, right? I mean, some of them incredibly offensive, some of them not. Some, we can't even really get at the cause of things because it's a web of causality, right? We are not even sure what the origins are. The symptoms. Remember the symptoms in the beginning, and then later we learned sometimes there's those symptoms and sometimes not. So we're changing the distinctions as we go. The treatments are changing constantly, and we're getting better and better, hopefully. The terms, there's lots of new terms, and those terms mean specific things. And if we don't understand the meanings, then we
Yeah, we needed time. We needed time to pass so information could get better.
can be confused by the system. And of course, there's many strategies and things like that that have names too.
They don't have Wu Flu on here. You need Derek. We need to add the Wu Flu. Oh, you got Kung Flu, Wu Flu.
does flatten the curve mean? There's been even something as simple as flatten the curve. We have different meanings. Different people think of that as a different distinction. So your distinction and my distinction might use the same word, but mean completely different things.
Totally.
Or we might use different words and mean the same thing.
Yeah, we were trying to flatten the curve last year, and that's right. It's a curve that then gets flattened and apparently comes back and then gets flattened again. So I think you're right. The language here really confused people at the beginning when they say, "Oh, we're going to flatten the curve," when it's going to be many curves. So the curve implied that it was one. When if more intelligent people than the layman who understand viruses would have come out and said, look, there's going to be probably three curves. In history, this has a repeating pattern. There's probably going to be three curves. One of them is more extreme than the other. And, we need to flatten, we need to be able to flex and move with all the curves, not one. Because it gave this perception to the population that if we just do this once, it's going to be over. And then you're setting up people for resentment for complying with that first participation of flattening the curve. And then there's another one and another one. And then they feel like they were duped at the beginning.
Right? And that's just a function of distinction making. And of course, there's systems of all kinds. There's knowledge, stakeholder system constraints, system structures, strategies, all those kinds of things. You can imagine lots of different systems that would have to be analyzed. And of course, there's relationships. Every XY graph that you see on the news is actually a relationship between the stuff on the x-axis relating to the stuff on the y-axis. And the tests, the cases, all these different things, right? It's 5G related to COVID or not, so et cetera. But it's not, by the way. Linear causality, absent causality, all relational. So success and failure both utilize the ST loop, but in different ways. And I want to show you two different ways. So let's look at the Bob archetype on the left. The Bob archetype believes certain specific things, right? Their mental model is made up of the virus is a hoax, no masks, it's okay to socialize, we need to open businesses and schools, and we can cherry pick whatever data we want. And we're going to fit reality to our mental model, so we're going to go that direction.
What
right?
the fuck?
And the Sue archetype is the virus is serious, wear a mask, stay 6 feet, wash hands, quarantine, test, trace, flatten, and exalt the data. And so that one's going the other way, fit the mental model to reality. Now I want to ask you, in these two archetypes, what happens if they're all Bobs? What happens if they're all Sues? And what happens if they're a mix of Bobs?
Well, they're screwed either way.
That's obviously going to make your system really, really different.
Yeah, it's
If they're
polarized.
All Bobs, all Sues, or all
Yeah, polarized.
a mix. But whatever happens on the left is all those mental models of Bobs, Sues, or mixed Bobs and Sues are going to manifest in behavior. That behavior is going to have collective dynamics, and then we're going to have results, real systems, real world results of the system, like how many people die, how many people get infected, how much the hospitals are overwhelmed, how many people get vaccinated, all that kind of stuff. So this is a great example of the distinctions that individuals are making, the way that they're seeing it, the perspective, the parts of the whole that they're seeing, the relationships that they're seeing or not seeing, and then you multiply that times all the Bobs and all the Sues and all the Bobs and Sues, and you get the emergent properties of this COVID situation. Oh, there's a question. Hold on a second. Evans. concern between distinction and definition, or why you chose. Yeah, that's great. So definition is really, definitions like what you find in the dictionary, right? Like, so the word car has a definition. Distinction is really about two elements, identity and other. So it's what is the identity of the thing? And by virtue of doing that, you create an other. So let me give you an example. If you have an organization that has a distinction, an identity called human resources, a department, then that's a distinction. And you can say what that distinction means, what an HR department does, and all that kind of stuff. But it also is embedded in that distinction, the identity of that, is that somehow your goal, your job, is to manage resources which are human, right? But there's an alternative distinction that could be made, different than the one you're making, which is maybe humans aren't really resources. That would be a completely different identity. That HR would be the other two. So when we start to think about the identities we're making and we consider the opportunity cost of that distinction identity that we're making is the other that we're not making, we start to realize that there's opportunity costs in the distinctions we make. And so we want to make sure that we make the right distinctions that don't have bias in them, or that have the bias that you're willing to accept in them. Does that answer that question?
Opportunity
so
cost.
Definition is a lot less complex, a lot less. Definition's kind of like, if you read something in the dictionary, that's the definition. But that's not the meaning of a word when it plays out in context or when it plays out in mental models. And then somebody else said,
That's good. That's beautiful. I'm going to stop that right there. I'm going to review that last part. I'm going to say review the last 5 minutes because I've got to go get something to eat. So review the last part about I lost it.
that you're willing to accept in them. Is that
Opportunity costs. About opportunity costs. And that's what we're doing here. Meta learning. So recorded this whole show so that I can go back to it. It's going to automatically upload to YouTube. I'm going to be able to go back and then synthesize my results and write my own sort of way to describe this to somebody else, my children. If you can explain it to a 5-year-old, you know it well enough. I've been reading this and studying Derek's work for some time now, so this video is my first live learning where I can be able to go back to the video in a meta learning fashion. There's his book, but now the video I just watched, because he just released this on Twitter yesterday. So I'm like, perfect, I'll watch the video because I know it's going to be good. And it was good. Thank you, Derek. That's awesome. And it looks like I'm going to be diving into more of this area that I really love. I love that Bucky came in here with the trim tab and then some of this ending part. But I got a good handle on it now. Now I want to apply it, which didn't come... I didn't see... We didn't get into mapping or the ontology of it, but that's okay. That is still stuff I want to learn. But I did the mapping myself. I went through and started mapping out relationships of ideas and concepts. So I am in effect mapping. This is mapping, right? I'm mapping out how I think about a complex topic, such as system thinking. I went over that at the beginning. I learned live, and I am going to review the video and write my own sort of short form story the same way Jack does for his visual, but mine's going to be a little bit different on explaining this concept to my children. And then I'm reinforcing the learning into my own brain, and then I can apply that at work and other places. So that's it for now. Thanks.